We are now going to detail what are the hyperparameters you can set in a neural network. In the second part, we will see different types of regularization that may help to improve the predictive performance of a neural network. To understand all hyperparameters you can choose when implementing a network, consider this simple network with 3 hidden layers. The first parameters you can choose define the structure of the network. Among them are the number of hidden layers, the number of neurons per layer. Then you must specify the activation function used in each layer, the output unit, depending on the type of output you want to obtain, and potentially add specific layers as dropout or batch normalization. Once the structure of the network has been set, you need to specify parameters needed to optimize the weights and biases of the network. You need to specify the loss, which is a quantitative measure used to optimize the network. You also need to choose an optimization algorithm. You have already studied such algorithm in a previous session. Since these algorithms are iterative, you need to choose initial values for weights and biases. We have listed the main features of the network. For each one, we are now going to see how to choose them. We start with the fundamental structure of the network, the number of hidden layers and the number of neurons per layer. First, note that there is no general rule to choose the number of hidden layers or the number of neurons per layer. Research papers often contain architectures that have good performances on specific tasks. You may want to read them and try these architectures as baseline. Remember that the best network architecture is task-specific. There is no general best architecture. Starting from such baselines, you may want to vary the parameters a bit by adding or removing layers or neurons and see how it impacts the performance. You cannot test every possible architecture due to the large amount of time required to train a single architecture. Beware, you may find some general rules on the internet which have no theoretical or empirical guarantee. We know that it is impossible to find a network architecture that has the best performance on all datasets. Therefore, you must take this type of general advice with caution. More involved strategies are data-driven. They are based on iteratively training and pruning, i.e. removing some neurons or layers in the network, or on more complex evolutionary strategies in which, at each step, you may add or remove some neurons or layers.